Hey guys, today we're going to look at how to factor trinomials. And so this is going to be a little bit different than the other factoring that we've done because with the other things that we factored, we were either factoring a binomial or we were factoring something with four terms with grouping, or we had some of those other situations where we were just factoring out a GCF, or we were looking at something that had a common binomial factor built into it. But this lesson is specifically about factoring trinomials. And so a trinomial, for the sake of what we're doing here, is going to be something that looks like ax squared plus or minus bx plus or minus c. And so it has three terms. One will be a squared term, one will be just a plain x, and one will have no variable at all. It is also possible, we won't do it in algebra, but it is possible to have a trinomial that doesn't have that exact breakdown of variables and exponents. But for everything we're going to do for algebra, we're going to have things that are x squared, x, and then nothing. So if you'll title your notes for today, Factoring Trinomials. And we won't worry about the I can statement and all that. I just need you to know that that's what we are doing today. So here's how we factor a trinomial. Remember, factoring means we're breaking it into things that we could multiply to get it. Basically, what we're doing, let me go back to this. Basically, what we're doing is we're taking something that is in this form and breaking it back down into two binomials that we would have used in the box that would have multiplied to give us this. So it's kind of like doing the box backwards. So anyway, let me erase that. So here's what we're going to do to factor a trinomial. We're going to call this method take 3 and make 4. The method is take 3 and make 4. Don't draw this, but if you think about it, when you multiply a binomial times a binomial, you end up with 4 things on the inside. And typically, not always, but 9 times out of 10, I would say, maybe more often than that, 2 of them, usually these 2, end up being like terms and can be put together. So you actually end up with 1, 2, 3 terms in your final answer instead of 4 because you're able to combine 2. So that's what creates the trinomial. What we're going to try to do, be able to factor one, is break it back into the 4 that it was to start with so we can then factor those 4 using grouping. That's the whole idea behind it. So first thing you're going to do always and forever, anytime you're doing any type of factoring period, is you're going to look for a GCF. If there is one, factor it out before you do anything else. That's not going to keep you from having a trinomial. You will still have a trinomial. But if there's a GCF, you need to move it out before you try to do this take 3, make 4 method. So the method for take 3, make 4 tells you to multiply your A and your C. Now I call this a magic number. So you multiply A times C to get your magic number. Then you're going to figure out what 2 numbers you could add to get B, that's your middle term, that you could also multiply to get your magic number. Solving one of these with take 3, make 4 is kind of like a puzzle. So if you're like, none of this stuff makes sense, what in the world is she talking about? Just wait and we'll do some of it and then you'll kind of get the hang of how it works. But you multiply A times C to get that magic number, and then you try to figure out 2 numbers that you would add to get the middle term that you could multiply to get the magic number that you got when you multiplied A times C. Then you're going to rewrite this as 4 terms. And the 4th term comes because you're going to split the B. And I'll show you what that means. and finish factoring with grouping. So you need these steps. This is the only notes we're going to have today, and then we're just going to work some examples. But you need all these steps, word for word. I'm highlighting them. I don't really know why, because if you have to write it all down, there's no point in highlighting them. So take the time to write them. If I move on before you're finished, pause the video, finish writing it, and then come back to it. All right, we're going to look at some examples. Again, if you're not done, pause it, write it down, and then go on to the next part. So write down example 1. X squared plus 7x plus 6. So before I ever start working this problem with take 3, make 4, I need to look to see if there's a GCF that I can factor out. The coefficient to this term is 1, which means the only GCF that you could ever pull out as far as coefficient goes is 1, and there's no reason to do that. So I know there's not going to be a number GCF. Let me look at my variables. X squared, X, no X at all. So I also can't take an X out because there's no GCF of X since a 6 doesn't have an X. So now that I know there's no GCF, I'm going to do what we call take 3 and make 4. So the first thing we do is we find our magic number, and our magic number comes from multiplying the coefficient of the first term by the coefficient of the last term. So since there's not a number in front of this, I'm going to put a 1, and I'm going to multiply 1 times 6 to get 6. That's my magic number. And so what I try to do is I'm going to try to figure out a way I can split this into 2 separate terms that would add to give 7, but would also multiply to get 6. So the easiest way to think about that is to think about the things you can multiply to get 6. Now, you don't have to make this list every time. I'm going to make a list just to show you my thought process. If you need a list, make the list. If you don't, if you think that you understand kind of the thought process here, then you don't have to make a list, but you might need it or you might find it useful. So things I could multiply to get 6, 1 times 6, or 2 times 3. And then I could go 3 times 2 and 6 times 1, but there's no reason to repeat if I've already got the factors done. So when I'm looking at these, this is the only 2 ways I can multiply and get 6. Let me see which one of those I can also add to get 7. 1 plus 6 is 7. So these are the 2 numbers that I'm going to split my 7x into. So 7x can be split into 1x and 6x, because 1x plus 6x would give me 7x. So I'm just taking that middle term and splitting it back into 2 as if it were still in the box with the 4 terms together. I've only split this one, which means this term still exists and so does this one. I'm just going to bring those down. So 1x squared plus, and then plus 6. It does not matter which order you put these in. If you would have put 6x plus 1x, you're still going to have the same answer at the end. So don't worry if you're like, well, which one do I put first? It doesn't really matter. Okay, so from here, once I get this into 4 terms, and I'm going to go back through how we just did that. I multiplied my 2 outside numbers to get a magic number, 6. I used that number to figure out 2 numbers I could multiply to give me this, but I could also add to give me the original middle term. I did 1 and 6. 1 times 6 is 6. 1 plus 6 is 7. Then I split that middle term into 1x and 6x. From here, I can factor with grouping. So this is what we did in the last lesson. I'm going to put parentheses around the first 2 and the last 2. I'm going to look at this and see what I can factor out. So they both have a 1 and they both have a single x. This one has 2, but this only has 1. So I can factor out a 1x. You don't have to put the 1 if you don't want to. You can. It won't be wrong if you do. And then left behind here would be just one of those x's, and left behind here would be just 1. You can't leave this out altogether because there's still technically a 1 there, because 1x times 1 would still be 1x. We're thinking multiplication. And then in this next set, they both have a 6, so I can pull a 6 out. They don't both have an x, so I have to leave the x, and 6 times 1 made 6. So I have to put a 1 in there. And then we end up with a common binomial factor of x plus 1, and then the leftovers that go in a second set of parentheses. So I end up with x plus 6, bring down the plus by the way, and x plus 1. It'd be fine if you wrote x plus 1 and then x plus 6. If you wanted to check and make sure this was right, you could multiply it back out using the box, and you would get back to this exact same answer up here at the top. Another fun fact, if you want to double check and make sure you were right, you could type the original expression in Desmos and type what you factored it into in Desmos and make sure they come out to be the exact same graph. And if they do, you would also know you were right. So you can check yourself even using the Desmos graphing calculator. All right, write down that second example, 4x squared plus 26x plus 42. All right, so when you look at this one, again, the first thing you want to do is check to see if there's a GCF. So 4, 26, and 42 are all even. So I know that at least 2 could be factored out of them. Let me see if 4 will go into everything. So 4 times 7 is 28. 4 times 6 is 24. So there's no way to get a 4 to multiply and become 26. You also couldn't get 4 to multiply and become 42. So we can't pull the 4. We can pull a 2 out, though. And then this has an x squared, this has an x, and this has just plain 42. So I can't take an x out either, since everything doesn't have an x in it. But everything does have a 2 in it. Everything is divisible by 2. So I'm going to start by moving a 2 out and seeing what I have left over as my trinomial. So 2 times 2 would make 4. X squared is still there. 2 times 13 would make 26. By the way, if you didn't know 2 times 13 was 26, you can divide 26 by 2 to get this number. And then 2 times 21 is 42. So this is the trinomial that we're going to take 3 and make 4 with. So at this point, this 2 that I factored out, I'm going to ignore it till I get all the way to the end, and it's just going to be part of my answer. I don't have to do anything else with that 2 because it's already been factored at this point. So I'm going to bring it down, and I'm going to ignore it for the rest of this time. So from here, I'm going to take these numbers and I'm going to find a magic number. And I do that by multiplying my coefficient of the first term with the last term. So 2 times 21 is 42. That's going to be my magic number. And I need to figure out something that I can split 13 into. That if I add it will give me 13, but if I multiply will give me 42. The easiest thing to do is to figure out things you can multiply to get 42. So again, I'm going to make a list just to show you my thought process. If you don't need a list, you don't have to make a list. If you're really good with multiplication, you may not find yourself in need of a list at all. If multiplication is not your strongest suit, you may need a list. It might be helpful to you. So I'm going to make a list real quick, just so you can see what I'm thinking. So 1 times 42 is 42. 2 times 21. 3 times 14. 4 won't go. 5 will not go. 6 times 7. And then we'd be back to 7 times 6 and so on. So these are the only things I can multiply to get 42. I need to see which of these I can also add to get 13. Well, 1 plus 42 is not 13. 2 plus 21 is 23, so that's out. 3 plus 14 is 17. But 6 plus 7 is 13. So 6 and 7 are going to be the two numbers I split my 13 into. So I'm going to put a 6x on one side and a 7x on one side. It does not matter which order you put that in. If I put 7 here and 6 here, we're still totally fine. So I've split the 13. I still have the 2x squared and the 21. So I'm going to bring those down and have 4 terms. That's the whole point. We're taking 3 terms, making them into 4 terms by splitting the middle. So from this, I factor with grouping. So I'm going to put those in a group and these in a group. And I'm going to see what's common. So looking at 2x squared and 6x, I know that 2 goes into 6. And I know they both have an x. So I'm going to take 2x out. If I take 2x out of 2x squared, I'm just left with that x that's left over. You can put a 1 in front if you want. 2 times 1 would be 2. You don't have to. X times x would make x squared. If I take 2x out of the 6x, 2 times 3 would be 6. X times nothing makes x. So I'm going to leave it right there. And then here, I look at 7x and 21. I know that 1 times 7 is 7. That's only two factors for 7. And I know that 7 will multiply by 3 to make 21. So 7 is common. I can pull it out. Bring down your plus. And then 7 times 1x would make 7x. And 7 times 3 would make 21. So I factored that out, taking the 7 out and leaving behind the x and the 3 that you would multiply to get that. And then once you get that common binomial factor, you write it down in one set of parentheses and you write the leftovers in another. It doesn't matter if you write the leftovers first and then the common binomial factor, or you write the common binomial factor first and then the leftovers. So that is the take 3, make 4 factorization, but you can't forget that you had a 2 that you factored out from the beginning. So the 2 has to be included with this as a part of your answer. So you leave the 2 like that, and then you bring the rest of it down. X plus 3, 2x plus 7. You're not going to multiply anything back out because that's defeating the purpose. The whole point of this is to break it back down into stuff you could multiply to get it. And so we don't want to multiply anything back out. That would be the factorization of this. Again, you could check it by doing a box. You would actually have to do a box. Well, you could do a box with this part and then distribute the 2. But you could do a box to check that if you really want to make sure you're right. Or like I said, you can type the original expression in Desmos and the factored expression and make sure the graphs are exactly the same. Exactly the same in exactly the same spot. I realize this is kind of complicated. It really takes some practice to get used to how it works. Bear with it. Keep trying. It will get easier. All right, let's do another example. So write this one down. 5x squared minus 14x plus 8. So when we look at this, we have a 5, a 14, and an 8 that we want to see if there's a GCF we can take out first. So the only thing you can multiply to get 5 is 1 times 5. And I know that 5 times nothing will give me 14 or 8 because they don't end in 5 or 0. So that means they're not divisible by 5, which means the only common factor these would have would be 1. And there's no reason to factor a 1 out because it doesn't change anything. So we're not going to worry about factoring out a GCF since there really isn't one to factor out. Now, what we have to think about here is that this minus sign, if you remember, if you look back at the other two, they both had addition in front of their middle term. And so we didn't have to think about anything as negative. Everything we worked with was positive. But in this problem, we have a minus sign here, which makes us think about this 14 as a negative 14. So when I go to break this down, I have to consider the fact that whatever I break it into has to equal negative 14 when we add them together. So with that idea in mind, let's get our magic number. So we'll do 5 times 8 and get 40. And I'm going to think about what two numbers I can multiply to give me a positive 40 that I would add to get a negative 14. Now, if you know your integer rules, then you'll remember that the only way to multiply and get a positive number is to do a positive times a positive or a negative times a negative. And so I know that I'll never be able to add two positive numbers together and get a negative number because adding doesn't work that way. But I could add two negative numbers and get a negative number. So when I think about this, I'm going to need to think about negative numbers I can multiply to get 40, not positive ones. Now you may be able to look at this negative 14 and automatically know what two numbers would add to get negative 14 and multiply to get 40. If you do, that's great. You don't have to do this next little part. If you don't know, like you're looking at that and you're like, I don't have the slightest idea, Miss Ware. write down the things you can multiply to get 40. And it may be a long list sometimes, but write them down because it's going to help. And since I know I'm going to want to get a positive 40 but a negative 14, I'm going to think negative numbers. So negative 1 times negative 40 would give me 40. Negative 2 times negative 20 would give me 40. 3 won't go into 40. Negative 4 times negative 10 would give me 40. 5 times negative 8 would give 40. 6 won't go, 7 won't go, and then we'd be back to 8, and I'd be back to this section. So these are the only pairs of numbers that can multiply to get 40. And so now I need to look at those and decide of those pairs, which pair will also add and give negative 14. Well, negative 1 and negative 40 would be negative 41. Negative 2 and negative 20 would be negative 22. Negative 4 and negative 10 is negative 14. So those are the two numbers I'm going to use to split my negative 14x into. So I have negative 4 and negative 10. Bring down my plus 8. Bring down my 5x squared. And then we will factor the rest of this with grouping. Now I'm going to grab the negative with that 10. I'm actually going to put my plus sign back in here. And we're going to remember that that 10 is negative. So when I do this with grouping, and I look at what I've got going on here, 5 and 4 have no common factors other than 1. So I don't need to factor out anything from the coefficients. X squared and x, though, we can factor an x out of both. So that's going to leave me 5x, because x times x is x squared, minus 4, because x times negative 4 would be negative 4x. Bring down my plus. Negative 10x and 8. Now with this, I know that 10 and 8 both share 2, right? Because 2 will go into 10 and 8. Here's what I have to be careful of with this. I need what I have left over to match this one so that I have a common binomial factor. So if I want to leave behind a positive 5x and a negative 4, I'm going to need to factor out a negative number so that the signs on these two will change. Because a negative times a positive would create the negative that I need here. Or a negative times a negative would create the positive that I need here. So I'm going to factor out, instead of a positive 2, I'm going to factor out a negative 2. Negative 2 times positive 5x would make 10x. Negative 2 times positive 8, negative 2 times negative 4 would make positive 8. So the only way for me to get my signs in this set of parentheses to match my signs in this one is to factor a negative number out instead of a positive number. So I'll end up with x plus negative 2. Easier way to write that would just be x minus 2. You could write x plus negative 2. You would not be wrong. And then 5x minus 4. So my outsides and my inside. I didn't have to factor GCF out, so there's not a number to put here. So that's just it. Again, you can check it by multiplying it in a box or typing this one and the original one in Desmos and making sure that the graphs match. Desmos won't work it for you, but you could make sure the graphs match and make sure your answer is right. All right. Let's look at this next one. Write that one down. 12x squared minus 48x plus 45. All right, so when I think about this, the first thing we want to do is look to see if there's a GCF we can factor out first. So I'm going to look at my smallest number and see what I can multiply to get it. And then I'm going to check these to see something else will go into that. So 1 and 12, 2 and 6, 3 and 4. Those are the things I can multiply to get 12. So 12 goes into 12 and 48, but not 45. 6 goes into 12 and 48, but not 45. 4 goes into 12 and 48, but not 45. But 3 would go into 12, 48, and 45. They're all even with 3. So I am going to factor a 3 out before we ever get started with the rest. That's a GCF. I don't need to factor out an X because this one doesn't, the 45 doesn't have an X on it, so we can't factor that out. So that's going to leave me with 3 times 4 would give 12. 3 times 16 would give 48. And 3 times 15 would give 45. Okay, so I've factored out my GCF. Remember, we're not going to mess with it anymore. We're just going to bring it down to the bottom so it'll be in our answer, but we don't have to do anything else with that. We now have to factor what's left in the parentheses. And we're going to do that using take 3, make 4. So I'm going to start by finding my magic number. 4 times 15 is 60. So it's a positive 60 that I'm trying to multiply to get, but a negative 16 that I want to add to get. So remember, we're going to still have this 4x squared, and we're going to still have this 15. And I'm going to break my negative 16x into 2 different x terms that will give me a negative number. Now, what I know is that I'm going to be adding 2 numbers together to get negative 16, but multiplying them to get positive 60. So we're going to be in the same situation this time that we were in last time, where we're trying to add to get a negative number, but multiply to get a positive one. So both of the numbers that I add together are going to have to be negative. So I know this number is going to be negative and this one, because the only way to add and get a negative number, but multiply and get a positive one, is if they were both negative to start with. So let's think about what numbers we can multiply to get 60. And again, if you can see automatically what 2 numbers would make negative 16, that would also multiply to get 60, you don't have to take the time to write this out. But if multiplication is not your friend, you might need to. So negative 1 times negative 60 would work. Negative 2 times negative 30. Negative 3 times negative 20. Negative 4 times negative 15. Negative 5 times negative 12. Negative 6 times negative 10. 7 won't multiply to give 60. 8 won't. 9 will not. And then we're up to 10, and we've already got 10 on our list. So looking at these, the 2 that multiplied to give negative or give positive 60, but you could add and get negative 16, would be your negative 6 and your negative 10. So I'm going to go down here and I'm going to put negative 6x in one spot and negative 10x in the other. Doesn't matter which spot you put which one. Once we have this into 4 terms, we're going to group them. Again, I'm going to keep that negative in with the 10 so that I remember that that was a negative number to start with. And so when I go to factor this side out, 4x squared minus 6x, I look for GCF between the two first. 4 and 6 are both divisible by 2, and they both have an x. So I can take a 2 and an x, which leaves me with 2x, because 2 times 2 is 4, and x times x is x squared. And 2 times 3 is 6, and I took the x already, so I don't have an x left for that one. And now when I go to factor this one, 10 and 15 both share 5. I know that. And then this one has an x, but this one doesn't. So I'm going to pull a 5. The thing is, my 10 is negative, so if I take 5 from it, I'm going to be left with negative 2x. But if I want it to match, so I have a common binomial factor, I need that 2x that's left inside to be positive. So the only way to make that happen is to pull a negative 5, so I can leave a positive 2x, because negative 5 times positive 2 is negative 10. And then if I take a negative 5 out of the 2x, I have to take negative 5, or out of the 10x, I have to take negative 5 from the 15 too, which will leave me with negative 3. These get tricky with these negative and positive things, especially if you're not great with integers. Just be really careful with making sure that everything here matches perfectly with everything here. If it looks like it's all going to be opposite, use a negative number so that it'll all match. because by taking a negative out, you'll swap the signs on everything that's left inside. And so when I go to write out my answer, my outside stuff, 2x minus 5, and my inside stuff, 2x minus 3. And then the 3 that I factored out to begin with has to be part of my answer too. So that is the factored version of this. And again, you can check it by putting this in Desmos and this in Desmos and making sure the graphs are exactly the same. All right. Remember how many more I have left. So I got 4 examples left. I would love for you, if you feel like you can, to pause the video at this point and try to work these 2 yourself and see if you can get them right. And then if you can't, or if you're struggling with it or whatever, come back and we will, or you can just unpause the video and watch me work through them. But it would be great if you were to attempt some of them yourself. I think that would be helpful to you. But I'm going to go ahead and start working them. If you want to try them yourself, pause it, and then you can check and see if you were right. So, anyway, here we go. So for this one, since x squared is by itself, there's not going to be a GCF to factor out because there's only a coefficient of 1. And you can't factor out a 1. So you have to multiply to get your magic number. So I'll have a positive 1 and a negative 45 that I'm going to multiply, which means this is going to be negative 45 for my magic number. So that means I need 2 numbers I would multiply to get negative 45 that I could add to get 4. Now, if I've got to multiply 2 numbers to get a negative number, that means one number is going to have to be positive and one number is going to have to be negative. That makes for some kind of tricky figuring here. So I know I'm going to split this 4 into 2 things. But one's going to be positive and one's going to be negative. It doesn't matter which one is which. I'm going to go positive, negative. Makes no difference though, really. As long as the math works out here. So let's think about what we can multiply to get 45. And then we'll talk about how we want to think about our signs. So I know that 1 times 45 is 45. 2 won't go, but 3 times 15 would. 4 won't. 5 times 9. 6 will not, 7 will not, 8 will not, and then we're back to 9 again. So these are the 3 possible combinations. Now, I don't know which of these is going to have to be negative to be able to make this work, but since I know one of them will have to be negative, I basically can think about this like subtraction, because a positive plus a negative is really like subtracting the 2 numbers together. So if I thought about subtracting 1 and 45, I'm going to get 44. Or I'm going to get negative 44, depending on which one is positive and which one is negative. So this is not going to get me a plain old 4. That one's out. If I do 3 and 15, if the 3 is negative, they'll combine and make positive 12. If the 15 is negative, they would combine and make negative 12. So this also does not work. 5 and 9, though, if the 5 is negative, negative 5 plus 9 is positive 4. Which is what I want. If I made the 9 negative, I'd end up with negative 4, which is not what I want. So when I write this out, I want to make sure that I consider that the 9 has to be positive and the 5 has to be negative for them to combine to give me a positive 4. So again, I worked through that by thinking about what I could multiply to get 45. And then I knew that one had to be negative to make it actually be a negative 45. So I figured out which one would have to be negative to get me a positive 4 when I combined them. And the 5 could be negative to keep my answer positive in the middle. So once you get that broken into 4, you multiply, or not multiply, you group them. And then we're going to factor out a GCF. So since this doesn't have a number with it, the only thing they have in common is x. So that leaves me with x plus 9. Now here, negative 5 and negative 45 both share negative 5. So negative 5 times 1 would be negative 5. So just plain old x is left. Negative 5 times positive 9 would be negative 45. And so I get x minus 5 and x plus 9. That is the factored form of that. Again, you can check it by multiplying it in a box, or you can type them both in Desmos and make sure they match. Either way will work. All right, again, if you haven't tried this one, but you feel like you are ready to do that, pause the video, give it a shot. All right, so for this one, there's not a GCF because there's a 1 here, and the only thing common could be 1. So I'm going to multiply. 1 times negative 15 is negative 15. And so I have the same situation I had last time where I've got to be able to multiply to get a negative number, which means I'm going to have one positive and one negative factor. I'll bring down everything that stays. I'm going to bring down this. I know that one's going to be positive and one's going to be negative. So I need to think about what I can multiply to get 15 that I can also add to get negative 2. So let's think about what we can multiply to get 15. 1 and 15. 2 won't work. 3 and 5. That's the only things that we can multiply to get 15. Now, if I combine 1 and 15, no matter which one is negative, I'm going to get either a positive or a negative 14. So that's going to be out. It's going to have to be 3 and 5. If I want them to combine to make negative 2, I'm going to need a positive 3 and a negative 5. Because positive 3 plus negative 5 makes negative 2. Once we get 4 terms, we do grouping. In the first term, the only thing they have in common is x, because this has a 1 in front. So x plus 3 is left. I took the x out of both. Had an x here and a 3 left here. For this one, negative 5 and negative 15 both share a negative 5. I would be left with x and positive 3. Negative 5 times positive 3 would make negative 15. And so my answer is x minus 5 and x plus 3. So my outsides go here, my insides go here. You also could have flip-flopped that and put the insides first and the outsides second. Doesn't matter. All right, one more set of examples. Again, if you feel like you're ready to try these on your own, do that. If you think you need a little more watching and learning, that's okay too. We'll do some practice on this on Canvas tomorrow anyway. So looking at this one, let's check for GCF first because we have a coefficient of a number here. So 9, 21, and 8. The only thing I can multiply to get 9 is 1 times 9 or 3 times 3. And I know that 9 will not go into 8 and 3 will not go into 8. So the only thing common for all of them is a 1. So there's no need to try to factor a GCF out this time. So I'm going to start by taking 3 or doing my magic number. So 9 times negative 8 is negative 72. Which means I have to find a way to break 21x into two numbers that would add to give negative, or would multiply to give negative 72, but would add to give positive 21. So if I need them to multiply to give a negative number, one of our numbers has to be negative. So it doesn't matter which one we make negative, we just have to make one of them negative, and one will have to be positive. So let's think about what we can multiply to get 72. So 1 times 72 would work. 2 times 36. If you don't know that, you can do 72 divided by 2 and get 36. 3 times 24. 4 times 18. I know 5 won't work because it doesn't end in 5 or 0. 6 is 12. 7 will not work because 7 times 10 is 70. 8 works, 8 and 9. Okay, that's all my list because I would go back to repeating at this point. So I need to figure out two numbers, one positive, one negative, that could combine to make 21. So I'm basically going to think about if I were to subtract the numbers, which numbers would equal 21 together. So 1 and 72 would make 71. 36 and 2 would make 34. 24 and 3 would make 21. So if I want it to be a positive 21, I need a positive 24 and a negative 3. Because 24 plus negative 3 would make positive 21. If I made the 24 negative, I would end up with a negative 21. And that's not what I want. I need my 21 to be positive. So I'm going to use positive 24x and negative 3x. And then I'm going to do grouping. Oop, I put an x. I was like, why is that so close together? Because I put an extra x in there. Sorry, y'all. And then we'll group this. So with these numbers, 9 and 24 share a common factor of 3, because 3 goes into 9 and 3 goes into 24. They also both have x's, so I'm going to take a 3x out. And that's going to leave me with 3x, because 3 times 3 is 9, and x times x is x squared. And then 3 times 8 is 24, so plus 8. We don't put an x because the x is already out front. Now for this set, 3 and 8 don't have anything in common. And this has an x and this one doesn't. However, if I just factor a 1 out, or just put a 1 out front, I'm going to be left with a negative 3x and a negative 8. And I need this, what's left, to match what was left over here, a positive 3 and a positive 8. So to make the signs that are inside of these parentheses match so that I can factor it, if I factor out a negative 1, that changes all of my signs, because negative 1 times positive 3 would have given me negative 3. And negative 1 times positive 8 would give me negative 8. So I'm going to factor a negative 1 out so that my insides still match. And I have 3x minus 1 and 3x plus 8. So if you're ever in a situation where your signs need to be flip-flopped, take a negative number out instead of a positive number, and that will flip-flop them for you. And that is the factored form. Again, you can check it in Desmos by making sure the graphs look exactly the same. All right, one more question left. Again, if you feel like you can, try it on your own. If you're not quite ready, watch again. First look for GCF. 8, 2, and 6 are both even, which means we can factor a 2 out. They don't all have x's, so we can't factor an x out. 2 times 4 would make 8. 2 times negative 1x would make negative 2x. 2 times negative 3 would make negative 6. All right, now I'm going to bring this down and ignore it. And I'm going to factor what's left in my parentheses. So in these parentheses, I'm going to make a magic number. 4 times negative 3 is negative 12. So I need two numbers that I can multiply to get negative 12 and add to get negative 1. So I'm multiplying to get a negative number, which means one has to be positive, one has to be negative. Does not matter which one is which. And so I end up with 12. So let's think. 1 times 12, 2 times 6, 3 times 4. So two that I could combine to get a 1 or a negative 1. Remember, if you know one's going to have to be positive and one's going to be negative, you'll think like subtraction. So 1 and 12 would make 11. That's out. 2 and 6 would make 4. That's out. But 3 and 4, I could get a 1. To get a negative 1, I'm going to need a positive 3 and a negative 4. Okay, so let's look at that. So positive 3 and negative 4 give negative 1. When I look at this part, 4 and 3 don't have anything in common, but they both have an x. So I'll take an x out and leave a 4x and a 3. because the 4 and the 3 stay. All we did was take an x away. Now, if I need this one to become 4 and 3 also have nothing in common, and they don't both have x's. So for this, the only thing I can factor out is a 1. But if I need all the signs to change so this matches that, I'll factor a negative 1. And that'll leave me with a positive 4x and a positive 3. So I end up with x minus 1, because my x and my negative 1, and 4x plus 3. And my 2 that I brought down and ignored gets put back with my answer. All right, that is the end of this video. This takes practice, y'all. It takes watching and learning and practicing and trying to get good at this. So if you're a little bit overwhelmed right now, we're going to do a lot of practice with this to help us get better. So don't fret too much. Expect to see some practice on this stuff tomorrow. Y'all have a beautiful day.